Okay, so this video is to give you an introduction into the equation of a circle if you haven't seen this before. So this is kind of a different style of equations. Instead of an explicit form, so instead of the usual y equals f of x, this is now implicit because we've got x and y on one side of the equation and we need this quantity to be equal to r squared. Now this, we're going to look at some examples, but this is very general. So this circle corresponds to having a centre of AB and radius r. But first let's look at an example just to get an idea of why this is true. So if we just look at the simple example that x squared plus y squared equals 4, then if we sketch this, this is going to correspond to a circle about the origin, and it has radius 2. So this is the origin, so 0, 0. And we see this is true because a and b both equal 0 up here. And the radius is 2 because r squared, 2 squared equals 4. But now let's see why this might be true. So if this is 2, then let's think about a general point on this circle. We can call this point x, y. And I'll think about what it means to be a circle. So every point on this circle has the same distance to the origin. That's what it means to be a circle. The distance between any points on this particular circle is 2 to the origin. So if we just think about drawing a line up to this point, then the length of this line is equal to 2. And then to derive this equation, what we can do is we can draw a right angle triangle. So I can draw a vertical line down here, so it makes 90 degrees. Let me just sketch it out again a bit bigger so it's a bit easier to see. So this is the same triangle. This is 90 degrees. And we said this length was 2. So the distance between the origin to x, y is 2. But since this is just the general point x, y, the x coordinate is x and the y coordinate is y. And then now we have a right angle triangle, we can actually apply Pythagoras' theorem. So if we just straight away apply it, this is the hypotenuse. It tells us that 2 squared equals x squared plus y squared. And this is exactly the same equation we have up here. So this is kind of where the whole form of the equation of a circle comes from. And we see why r is the radius and not r squared. It's because we need to take 2 squared. So we need to apply Pythagoras to get this squared. And then if you think about more generally of a circle that doesn't have centre of the origin but has just an arbitrary centre AB, the way we get this equation is instead of having x and y, we just apply a shift. So these values now become y minus b and x minus b. And then you apply Pythagoras to this triangle and you get exactly this. So this is kind of where the idea of this equation comes from. So I'm just going to wipe off the board and then we're going to look at another example. Okay, so now we're looking at an example of the equation of a circle in a more general form. So first let's sketch this. If I draw out the xy plane, then if you remember, the center of the circle is where these brackets equal 0. So the center is going to be when x equals 5 and when y equals 7. And also the radius is just this number here, so the radius is equal to 4. So I can draw a rough sketch. If this is the center, then it's going to look something like this. It's going to stay in this quadrant. And now a question we can ask is, if we're given one of these coordinates, so say if x equals 3, can we work out the corresponding y coordinates that satisfies this equation? So we're looking at a point, I'm calling it P, and this has coordinates 3 and y. And now let's think about what this means graphically. So we're essentially asking, where does this circle intersect the line x equals 3? So I can just sketch on the line x equals 3. It's going to look something like this. This is point 3. And then we see that this line has 2 points of intersection with this circle, here and here. So we would expect to see 2 solutions. If we plug in x equals 3, we'd expect to see 2 solutions to this equation. So let's do that and try and find out the possible values of y. So if I just put x equals 3 up here, we have 3 minus 5, so I'll just write it 3 minus 5 squared plus y minus 7 squared equals 4 squared. And so this is minus 2 squared, which is actually equal to 4. And then this is still y minus 7 squared. And I can evaluate 4 squared is just 16. And then I can just bring the 4 onto this side, and we get to y minus 7 squared. This is equal to 12. And now we have a squared here, so we can take square roots. And this is going to give us y minus 7 equals the square root of 12. But be careful because we need to take the plus and minus solution to this equation. And this is because if you think about going back up to this line, then we need to square this, and then we see that both the positive and negative values of this number square to be equal to 12. So this is why we need the plus or minus square root here. And then I can just bring the 7 onto this side, and we get y equals 7 plus or minus the square root of 12. And this is what we wanted to find. So these are the y coordinates that correspond to this x value. So we actually see we have two solutions. One where we take the plus and one we take the minus. So we have 7 plus the square root of 12 and 7 minus the square root of 12. And we see this one's bigger than this one. So if we think back to our diagram, then this point up here, this is going to be the larger value. So this is 7 plus the square root of 12. And the one down here, this one is 7 minus the square root of 12. And just the final thing to say is that if instead of given the x coordinate we were given the y coordinates, we would also be able to find the two corresponding x values, because then we'd just draw the horizontal y line and we'd again get 2 points of intersection, but this would correspond to two x values. So it'd be the same method but for y instead of x.